Hey everybody, this is Larry. This is day 21st of the October Leetcode Day Challenge. Hit the like button to subscribe and join me in Discord. Let me know what you think about today's poem. Yeah. Don't really have much to say today. I had something about, maybe I'll save it for another day. I was going to say something about expectations and stuff, but I have a backflip video if y'all are familiar with that. But if you're not, let me know in the comments. I'll send a link. But yeah, I'm just thinking about through my marathon journey from last year and this year, and just going through it. I mean, I am about 13 days, 12 days, whatever it is, to the marathon, and just reflecting. And now that I'm kind of doing more easy runs, I'm kind of reflecting on what's going on in it. Honestly, a little bit scary to kind of see how it goes. New York Marathon is one of the harder of the major ones, so we'll see. Anyway, all right, let's take a look at today's problem. We have 3346, maximum frequency of an element after performing operations 1. A very long title. You are given an integer array nums and 2 integers k and number of operations. You must perform operation number of operations time on nums, where each operation you select an I that's not selected. Okay, so you have to select an I that's not selected. So add an integer from -k to k to nums of I. Return the maximum possible frequency of any numbers in nums after performing the operation. Okay, so the index I thing just means that you have to, you just don't use anything, right? So given that, for example, example 1, your number of operations is 2, you have n is equal to 3, so you have to choose 2 of them, right? I think I think this is pretty basic. I think the idea here is just, and the first thing that I would try to think about is how to brute force, right? Or how to, not even brute force necessarily, maybe brute force is the wrong word, but a way to try every possibility. Yes, in essence, that is brute force, but maybe you could do it in a smart way, right? And the way that you may think about that is to kind of reword the problem in a way that can happen. In here, return the maximum frequency. Maybe instead of maximum possible frequency, we reword the problem as try all these frequency in all of one time or whatever, right? Maybe log n, but for this one, all of one, right? And take the max out of all of those. And, as long as you're able to select candidates like that, then you are pretty good, right? Keeping in mind that you have to perform, you have to perform it, so you so you have no choice in the matter, right? Like it's not up to, it is you have to. I guess that's the distinction I'm trying to make, even though I said it in a little awkward way. So I think after that, then now we think about, okay, the first thing is that what we want to do is give the input structure. You can sort it, but which we will do anyway, but I would also want to put them up in a frequency table so that now all the numbers are kind of aggregated together, right? Grouped together in a very natural way. I think for me, for this problem, the must operation is a little bit tricky, but really, given 10 to the 5th numbers, we only really have wait, what? K? Oh, wait, which one is K? Oh, K is the number of operations is this. Okay. Keep in mind that for this one, right, because basically each number can, not change, add K, subtract K, then there really is only 3 times n the number of possibilities we have to consider, right? Because every other number that is not in these 3 times n scenario, they would just not appear in the result, like literally, because no numbers can hit them. So that's basically how I would think about it. Yeah. And there is like some weird edge cases with the must, so we have to be a little bit careful. But I think we should be okay, right? For example, what I mean is that like if you have, I don't know, 1 and 10, I don't know, 0 and 10, right? Maybe it has to be only be positive. I don't know. Okay, the inputs are only positive, but whatever, right? And then k is equal to 5, right? So we have to, let's say that's the input. If we have to or maybe 0, 5, and 10, right? K is equal to 5. The idea there is that if you have to choose if op is equal to 3, number of operations is 3, then you cannot meet, or 2 of the numbers can meet at 5, but this 5 are forced to actually not meet at 5, right? So I mean, it's not that hard. We have to do some if statements, but or whatever, but just a thing to think about. Okay, and that's, yeah, let's think about that then. And yeah, and we could do a nums sort, right? And maybe we have a best is equal to, I don't know, just set it to some initial thing. Oops. And you could maybe even just look at the keys. I don't know, it's fine, right? Fine, we'll do it that way instead, right? So then now for current in, like I said, f of keys, it actually doesn't even have to be sorted. I guess I'm always very used to sorting things. And as I always say, sorting, I mean, obviously in an interview, etc., you want to talk through this and explain it. But outside of an interview, like on Leetcode and competitive, I will just sort anything because it's n-log-n. It is a very cheap n-log-n because it's very optimized n-log-n, because in every language, sorting is just a very fundamental thing. So it's usually pretty optimized and pretty fast. So you can even forward anywhere and it's free, basically, right? Of course, not, if it doesn't give you the wrong answer, which for some problems it might. But anyway, so then now we try current. Right, so then now we just take f of negative k, or current minus k, right? Count is equal to this plus this, right? So this is just the number of, and technically this actually, actually I think, excuse me, I have a sore throat. I actually should do a cough drop. But anyway, the reason why I'm hesitating a little bit, and you have to be careful, and this comes with experience and stuff, is that this actually mutates the keys part. So that's why I'm like thinking, okay, well, you actually have to save it then, right? Because if this is 0, I mean, you could also do things to check it, but this is just easier to write. Okay, so these are the things that we want to move, right? So then now, maybe ops is equal to num operations, right? So then this is the maximum things that we can move. So then now, yeah. So then, yeah. So min of count and ops, that is going to be a possible answer, right? Yeah. So moved maybe is equal to this, right? And then now ops we moved, right? And then now if ops is greater than 0, then we have to check that. This is why I'm like very slow, because I'm trying to think for the cases. If ops is greater than 0, we're going to see if we can move other numbers that are not current, right? Yeah. So then that is basically just going to be, so you want to, if we have operations left over, can we move other numbers so that we don't move current, right? And then others is going to be equal to n minus count minus f of current, right? So then now, yeah. So then now ops, we just kind of, these are like 4-way operations because we have to do it, right? So then now if ops is still greater than 0, then now we have to move current away, right? Yeah. And yeah, I mean, yes, but yeah. But I just wanted to write like maybe total moved is equal to moved plus f of current. This assumes that we don't change. And then now if this is still greater than 0, we still have operations left. So we have to move current. So then that is just going to be total moved minus min of ops. I guess by pigeonhole, this would always be ops because ops at this point cannot be bigger than f of current. But writing it like this is almost free. So yeah. And then now we just do best is equal to max best total moved. And if I haven't misread the problem, hopefully this should be good. It's very easy to misread problems. Okay. These test cases are kind of terrible, right? So I'm not very confident. I'm honestly also very lazy and tired, but let's try this real quick. Right. I mean, this is the example that we set. Maybe this we can try 2 of them where we have. Yeah. They expect 3. Oh, I misread this one. Oh, I misread this one. I did misread this one. For some reason, I read this as added integer negative k or k, not in the range. I missed the word range. All right. Another read fail by Larry. But, I mean, okay. I mean, I think it's not that bad. I mean, in the sense that, you got a free problem solve for free, right? So, okay. What a fail. Okay. I mean, this is basically sweep line, right? We can, let me draw it up real quick. I mean, this is actually much easier. I was actually wondering, like, man, there's a lot of edge cases for this one, so I have to be a little bit careful. I'm coughing a lot, so I'm going to get a cough drop because I was hoping to just finish this up and be like, okay, well, and do it offline. But give me a second. But don't want to keep coughing. Gotta reload my throat. What a fail. Okay. Alright, let's try again. With the correct problem this time. And that's why you test stuff, I suppose. But okay. But the idea here is just that, okay, you have some number. The idea is that you have some numbers on the numbers line, right? And then for each number, you and I like to draw these things because I want to show like what kind of visualization ideas that I have. Also, with enough practice, I don't have to draw them out, but I have the same idea, right? Oh yeah, so maybe they move k. Okay, that's too small. So maybe like this one, the k would go from it goes off screen, so go like this. This one maybe goes like I don't know, like this, and so forth, right? Dot. And then the idea here is just that now every number is just a segment that represents a range or an interval. And then as a result, then yeah. As a result, you can it's just the most overlap intervals, right? Which you can do with sweep line. And that's really it. Yeah, I mean, I think there are other ways to solve it, but yeah, that visualization is kind of crap. All right, can't believe I misread this. Oh wait, I missed a thing, which is that, man, I'm just misreading a lot today. I missed the number of operations equal to 2 part. I mean, it's still the same. We just kind of yeah, I mean, I think the idea that I said here is still true, right? Except for now, because here which is that now we're trying to look to the left, to the right to see how many numbers we can get into the same range. The only thing that is different is that I thought it was exactly negative k and k and not in the range, right? Which actually could be an interesting future problem, I suppose. But as a result of the exactness, you can do these in all one time. But because it's a range, then now we want to be able to do that in, well, less time, right? I guess you can always just do like a, there's so many ways to do it, really. You can also do just binary search, right? But you can also do 2 pointers, right? For each, numbers, for each number. Because the idea here is that you only, is it true still? I guess it's not true anymore, actually. Because I was gonna say, I guess the idea here was that there's only 3 times n number of possibilities, but it's not true anymore because you can have like 1, 8, like 2 numbers, k is equal to 5 or something like that, and these actually intersect at, I don't know, it could be anywhere, but it could be like even at 3, right? So it doesn't have to be that. Yeah, it doesn't have to be anymore. Though in a greedy way, you would always only choose current plus k. I mean, this, yeah, I don't know. Yeah, you'd only choose current plus k anyway, right? Is that true? And minus k in the same idea. The idea being that there's nothing interesting inside, right? Like it's not a critical point, which is, I guess, where you have this interval idea from. All right, I'm not going to do it that way. I am just going to do it with binary search because I'm a little bit tired at this point. Sorry, friends. I don't have the endurance for these kind of problems. Or just endurance today. I really need my sleep. So yeah. So now we sort. As we said, we can sort. So let's sort. So then now for x in nums, right? So then now we want to. Now we just want to binary search, right? We want to search x minus k to x plus k, right? Then this is left, right, and then right minus left is equal to count, right? So these are the numbers that are within that range. Actually, we still need the frequency because those are the numbers that we don't have to move, right? I mean, in this case, we're not forced to move, so we are forced to, but you could just choose 0, right? So that where before I didn't know that you could. So then now it's just going to be, yeah. So how many moves does this need, right? It's going to be f of x. Count minus this is the number of moves, and then we have number of operations is the most that we can do. So best is equal to f of x plus this, right? I think. And of course max of best in this. Alright. Hopefully this is a little bit better. Let's give it a spin. Alright, looks better because I read the problem correctly this time. But yeah, but this is basically just checking out the left endpoint, right? Like you have an x, and then just check out x minus k, and how many things are kind of inside that range. Is this right? Doesn't seem. Yeah, I thought it doesn't. I thought it was missing a case. That's why I was like, okay. Because here, man, sorry friends, I'm really off today. But here I was saying that this is only considering stuff. Where this moved, right? But like it doesn't count, which is why I have this edge case where they both moved toward the middle, right? So I think you could fix that by maybe just doing this, assuming that the other also just add or subtract k. And now this is wrong, huh? Why is this wrong? I output 3, expected answers 2. Oh, I see. Because it assumes for some reason that we moved to 2020 to, I mean, they moved these two together to the middle. So I guess that you can't just bisect it, huh? I guess the idea is still the same as before, but we just check the critical points, right? Which is that we just have this, and then now, which I guess you probably could do with like a sliding window, but you can also just do this, where I don't know, for current and for x in current plus k, current minus k. I think that's more specific. Yeah. All right. I think they simplified to the same, but I was wrong. Sloppy with the running time, but it's fine. All right. Pretty sloppy day today in general. But you know, the reason why we made this change. Sorry, I'm like still. I don't know, body's processing the cough drop and stuff. But yeah, the idea is that for every binary search, we go, okay, well, X is not moving, right? Or, or rather, we move everything to X. What is the cost? Well, if we move everything to X, everything that's within X minus K or X plus K can move to X. So those are the two numbers, right? And this is where we get the count. It's just the index subtraction. And then this is just the number. Well, the things that don't have to move is the things that are f of x, right? Because they don't move. So then, yeah, but we have to. We are limited by min operations. So that's why we have a min. And then this is just the count of things that don't move, right? So don't move and things that have to move. So to handle the mid in the middle case, we just check. Well, try for x is equal to x current plus k. Of course, in this case, f of x would be 0 potentially. I mean, in theory, you can also meet. Like in theory, that could be a place that we met. But yeah, if it's x plus k, then now you have 2 points and meet in the middle, and then we just same math, right? We just want to see how many things are within that spot. This would probably be 0, this probably 0, so then it just gets dominated by this part. And that's basically the idea, but man, today I am sloppy. I am going to get some rest. Thanks for watching. Oh yeah, complexity. I mean, we have sorting here, O of n here, double log n here, right? So n log n, pretty straightforward, I hope. That's all I have for today. Thanks for watching. And before I go, I want to say, man, I mean, I'm not a big chess guy. I know all the chess I know is all about competitive programming, or like from competitive programming or whatever. But man, today there's a sad news. Daniel, the GM with a lot of like educational videos. You could almost say like, I mean, he's a better version for his stuff, but like of what I'm trying to do with Leetcode and competitive, right? So they're just crazy. At 29, such a young dude passed away. So I don't know. Life is short, you know. That's all I have for today. Let me know what you think. Thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.